of actionability, how it is defined, increased. So what we did was just basically comparing, okay, let's see if there are recurrent structure and recurrent themes that happen when there are actionable or unactionable comments. And what we notice is, in general, but that's just to identify how can we improve the classifier we use. You classify it performed really poorly, out of the box, really poorly on the actionability on Twitter. Just to answer to your point, can be done automatically. What we start looking and say, right, can we build grammars? Can we build rules? One of the things we noticed in actionable tweets was that they were more about like themes about politics and then law and order, and that was were automatically extracted those themes, whereby comments about entities, name entities, like the characters on the panels, were not actionable at all. They had a sentiment, but sometimes you don't particularly care about whether somebody likes the dress of a panelist. You're more interested and say, okay, so somebody is angry about something. Is anybody making a suggestion of what should be done? And can we tap in and just get rid of all the fluff that there is in Twitter? So we're just at the very beginning of that.
The BBC Question Times dataset had comments that led to outcomes of some kind?
I don't know, but you know, we didn't measure whether those actions were taken. But what I'm looking now is the riot cleanup, how it all started. And then I want to kind of overlay a bit of ethnographic research, like just interviewing the actual people who started, and then see their tweets, like if they have a higher content of actionability, respect the average, in addition to see how maybe the number of followers. I mean, you have quantitative data, okay, so that's there for you to use, but also it would be interesting to see how those people that creatively make suggestions and their suggestions are acted upon. At the end, it would be just to do it automatically.
Okay, so they'll get the feedback. The eventual goal might be a feedback loop from expression through to satisfaction of something. Interesting.
Cool. Great. Okay. Thank you very much. Thank you. Would you like your laptop?
Yeah.
Why not?
Thank you.
That's great. Thank you. Right. So, without further ado, I'll introduce our very last speaker. So, everybody, this is Nigel,
or Sleepy Fox, as I am more commonly known in the community. Because that is my Twitter hashtag, amongst other things. So let's log in and see if we're live.
Come on.
Something there.
Success. Yes. Would you like to use this
With
as
a little blue book.
Oh, he's gone now. He's fine.
Okay. No.
I'll leave you alone.
It's working, so can we possibly have the lights up a bit? Because after a couple of beers, I'm falling asleep, and I'm sure the other people in the room probably are too. So originally this was about text processing, and when the invite came, do you want to talk about text processing? Because I said probably something I shouldn't have said after having a few more beers down the pub after the last event. About the kind of stuff that we do. I originally thought, well, actually it would be nice to look at perhaps old school styly text processing, because there's a lot of stuff that you can do with Unix, and most of us are probably technical. Hands up, anybody who's technical, who does any development work or coding, or it's kind of most people. But unfortunately, I was told no. So instead, I'm going to talk about Sunburst, which is something a bit different. So backgrounds. Who are source sense? SourceSense who I work for, are a small boutique consultancy with offices in Rome, Milan, Amsterdam, and London. And what we do is open source and mostly around the various different sort of Apache products. We were founded by a VP of the Apache Foundation, so we've got strong ties with the Apache Foundation. We have lots of different committers to various different Apache products, and in this kind of area we have committers to Lucene, Solar, the Nutch ticker kind of ecology of products, UIMA, which is the Unstructured Information Management Architecture, which is all about processing text. So we have a background in this area, and we're hiring. Can I say that?
Yeah, that's fine.
Sorry. So what is Sunburst? Solar. Just hands up who's familiar with Solar and Lucene. So that's ish half of the people in the room. Solar is an open source search infrastructure based on Lucene, and we do a lot of work with Solar, and we have a customer who called Moreover, who we can talk publicly about, whose business is providing people with information, and typically their customers are blue chip corporate clients like BP, who want to know what's being said about them in the press, in the blogosphere, on Twitter, across the internet about, you know, oil spills in the Gulf or whatever. And their clients are willing to pay money for this. So, you know, we don't unfortunately have the luxury of being able to just play with stuff that's really cool from an academic perspective. But we do some interesting things. Now, what I'm going to do is I'm just going to talk you through a little bit of context about the kind of problem that we had and why we're there, and then show you one possible solution that we have for the problem that we found, and then kind of open it up and hopefully get a little bit of discussion. So, where are we now? Anybody recognise the photo? No, not entirely surprising. This is the Berkeley Pit in Butte, Montana. It's one of, if not the largest US Superfund site, which means it's a disaster area. It's one of the largest areas for open-cast copper mining in the world. And this beautiful little lake that you can see here is about a mile long, about half a mile wide, and about half a mile deep, and is filled full of water that is so acidic with metals that have been left behind from the open-cast mining and smelting that it actually has about the same pH as battery acid, and they have mined copper from the water in that lake. Now, why am I mentioning Superfund sites? Well, some of us have the luxury of doing greenfield development, and the rest of us have to go in and work for clients with legacy systems where sometimes things aren't quite, perhaps, working as well as you might have hoped. So, solar. The usual configuration for customer solar systems, what we're very familiar with, is that you have a certain amount of content, sometimes moderately large amount of content, and this content is optimized for drip feed indexing of new content as content authors put new stuff in, and high volume search from hordes on the internet. However, Moreover is different. It's the other way round. Because essentially they have a small volume of blue chip clients who are doing very highly valuable searches, but they're indexing kind of the whole internet-ish. They're more interested in authoritative sources like Press Association and Reuters and various other news feeds, but they do monitor all of the blogging sites and all of the microblogging sites and a whole bunch of other stuff. So what are we really talking about? They index approximately 3 million documents every day. They have a 60-day archive, and that's more due to operational constraints than anything else, which gives them about 180 million documents in their index. And they only have about 10,000 searches per day, so that's about one search every few seconds. So that gives you an idea of some of the kind of optimization strategies. Their architecture looks a bit like this, and there's news on the left-hand side, and which is all of the authoritative stuff, and there is social media on the right-hand side. And these little boxes are Solar instances, they're shards, and we have a coordinator on each side of these, and archives. Now, so we have 2 rows, each row has 20 shards and a coordinator, and the partitioning algorithm is really simple. It's just a mod 20. Each shard has a Solar instance, an indexer, an optimizer, a committer, and a purger, and anyone who's familiar with Solar will go, okay, you know, that's pretty standard. What happens is documents are retrieved by the coordinator in blocks of 500. They're then allocated IDs by the partitioning scheme, and the shards individually poll the metabases, which are the 2 big things at the top, for their content as determined by the partitioning scheme. And the coordinator, amongst other things, archives that content. Now, this has presented a few issues. One of which is that coordinators are actually responsible for 2 different things, archiving and coordinating content as well as routing searches. And now from a software architecture point of view, you know, this is not as efficient as it could be. We have redundant data flow from the metabases because the instances are polling. And the partitioning scheme means that if we want to add more shards to each row, then we're forced to move n-1/n% of data across shards, which obviously means that scaling up horizontally is exceptionally difficult with this kind of partitioning scheme. So there are a number of different challenges there. We wanted to look for a better way of doing this. And one possible future, I should put a unicorn and maybe some like squee bunnies in there as well. What we would do is we would move towards a more generic distributed worker model where we would have worker pools of indexers, searchers, archivers, content coordinators, content enrichers. And it's worth noting that we do all of the stuff that people have been talking about with respect to people, places, and events, matching up from internal sources rather than, say, OpenCalais, and doing sentiment analysis and all of the other good stuff that we have there. And look to move to something more like this. So what's happening here is, this is a typical pipeline model of, we have a queue of stuff waiting to be ingested, it's passed along, sorry, show little arrows in here, it's passed along to an enricher, which then looks at reference data systems and does notable association analysis, or for people, place analysis. It's passed to the archiver, which then stores it in the archive. It's passed to the indexers, which then correspondingly put it off to the correct Solar shards for indexing. And this would be, of course, a separate workflow from the search retrieval workflow, and would be managed differently. And the coordinator would actually be coordinating rather than doing some archiving kind of on the side when it's not busy. Now, it seems to us that looking at this kind of pattern, this looks very much like what an enterprise service bus does. It coordinates pools of workers, it handles messaging between pools, it handles queuing, it provides a REST interface for nicely shuffling things back and forth, and of course it has a runtime container. Now, because we're an open source company, and because we have strong ties to the Apache Foundation, when the only tool you have is a hammer, every problem begins to look like a nail. So, what we've been looking at doing with this, and the solution that we've been starting to work on implementing, is based on Apache Service Mix for service orchestration, Apache MQ for messaging, CXF for REST services, and Carafe as an OSGI container. And again, this is, if you know anything about Service Mix, or we've worked with FuseSource or Mule or one of the many other ESVs, then this is not, as it were, rocket science. Now, I guess the main thing that I want to say here is this is us looking at the solution from our own perspective and going, oh, well, it kind of looks like, this is a sensible approach. But what I'm interested in hearing from you is, do you think this is a sensible approach, or actually would you do it differently? And if so, how?
Well, I'd stick my neck out and say no.
Go on.
I think I think, for example, RabbitMQ is what we use for one of our messaging classes.
Mm-hmm.
But the pipeline, the parameters of integrity in that pipeline is where it comes down to. So if you want to commit something, how long before it's eventually searchable, or in fact even consistent in a key value store like Cassandra, for example. So it depends on what, if a piece of news comes in, does it within seconds need to be searchable?
We don't get those kinds of constraints, no.
You don't?
They're laxer than that.
Right, because it just seems there's too many names there.
To be fair, Service Mix already integrates these things.
Yeah.
So it's not like, random name pulling from the ether. These are all technologies that are known good to work together.
Yeah.
I was just going to say, in terms of Twitter feeds and one thing or another, it's easily possible. I'm working on the commitment even much to get that stuff instantly searchable, more or less, running cron jobs with Nudge. So that's possible. The question that I had was, obviously the web being quite a dynamic place, and Solar not liking changes to schemas. How do you get around the addition of fields to schemas, or taking parts out of schemas, or mixing and matching parts of schemas to suit your search requirements without re-indexing possibly terabytes of data, or depending on how much you're going to gather? Because that's one of the main problems with.
And the answer is pragmatically. We're trying to figure out what I can say and what I can't say. The easiest answer to this is